All right, guys, today we're going to talk about slope and parallel lines, and that's going to be in your notebook on 84 and 85. So we'll label those pages. And of course, I did that without an erasable pen. 84 and 85. 84 and 85. So 10.1, slope and parallel lines. .1 slope. We are going to do both pages today. Zoom in so you can see that, and I'm labeling 85 the same thing while you're writing that down. Okay. So, we're going to talk about something called slope criteria for parallel lines. Which you technically already know this. It's just what's true about the slope of parallel lines. Two non-vertical lines are parallel if and only if they have the same slope. So you already knew that. We're looking for something that has the same slope. Okay. We're actually going to prove things about certain shapes and figures based on their slopes. So you need to tear out page 498 and 500 from your book. 498 and 500. All right, from page 498, you need numbers 4 and 5. Glue that right here. I gotta cut off some of this extra over here because it still won't fit quite right. Glue that right there. Okay, we're going to work that out, and then we'll talk about what's on page 500 in a minute. All right, so it says show that each figure is the given type of quadrilateral using the fact that we have parallel lines, okay? So number 4, show that JKLM is a trapezoid. A trapezoid has at least one pair of parallel sides. So we need one pair of parallel sides. So we can look at the figure and think about which ones we think are parallel. Looking at this figure, it looks like JK would be parallel to ML. So let's find the slope of those and see if they actually are parallel. So let's find the slope of JK. Okay, so we're going to go from J to K, to go down 2 and over 1, 2, 3, 4, 5, 6 and reduce that. So the slope of JK is negative 1/3. Okay, now we're thinking ML should have the same slope. If it does, it means they're parallel. And that's what we're hoping for. If not, we're going to have to keep looking and see if some other sides are parallel. So from M to L, I have to go down 1 over 1, 2, 3. Okay, these are the same slope. So since these slopes of JK and ML are equal or the same, the segments are parallel. Since JK is parallel to ML, JK LM is a trapezoid. Because I just had to have one set of parallel sides. Okay? And my screen froze because of course it did. Why wouldn't it? There you go, there's that one. All right, number 5 says show that ABCD is a parallelogram. Think about what the definition of a parallelogram is. The definition is two sets of opposite sides are parallel. So you have to show both. I want you to pause the video and try number 5. Okay, now that you've paused it, we're going to have to find the slope of the opposite sides, and if both of them are parallel, or sorry, both of them are the same slope, then that means we have a parallelogram. So let's find the slope of AB first. I always start with the leftmost and go to the rightmost. So rise over run, I'm going to go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, which reduces to 3 halves. Okay, and now let's find the slope of that opposite side, which is DC. If you put CD, it's the same thing. 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 3 halves. Okay, so that means AB is in fact parallel to DC. Good. Let's find the other set. So let's find the slope of AD. So I had to go down 2 over 1, which is just -2. Okay, and let's find the slope of BC. Down 2 over 1, -2. So therefore, AD is in fact parallel to BC. Now, some of you like to write almost nothing, and you're thinking, I don't need to write all this. I can just see. They've got the same slope. This is your work. This is your proof. You have to write that. Let's write a sentence now. Since both pairs of opposite sides are parallel, ABCD is a parallelogram. Okay. Now we're going to do a couple from page 500. You need 7 and 8 from page 500. And that's it. You can throw away your papers after you get 7 and 8. And here's how much of 7 and 8 you need, and it's going to go on 85. All right, 7 and 8 say find the coordinates of the missing vertex in each parallelogram. So we're going to graph these first, and then we've got to decide what the missing vertex is. Okay, so -3, -2 is J, 0, 1 is K, 1, -3 is M, and I'm going to have to find L is what's missing. Now, here's what you need to know, which will help you, because if you're like me, you're thinking, well, L could be over here, it could be over here, it could be over here. No, It's the order they say it in, okay? You go clockwise. I really had to think about that. Okay, so it goes from J to K, so J to K to L to M. So that means L has to be over here somewhere. So it goes clockwise. So you connect them in that order. You connect J to K, K to L, but we can't yet. L to M, we can't yet. M would go back to J. So here's what it looks like, and we are missing L. To find L, we are going to have to think about slope. So what I mean by that is JK and ML should have the same slope. So we're going to see what the slope is from J to K and repeat that process from M to L. So from J to K, I have to go up 3 and over 3. So to get to L, I'd have to go up 3, over 3. So L should be right here. We're going to draw this. Does this look like a parallelogram? We could check by checking the other slope. So we're thinking L should be here. Let's check the slope. This one is down 1 over 4. Down 1 over 4. I have done it correctly. That means my answer is L is located at 4, 0. Okay. Graph number 8 and see if you can find the missing vertex. All right, the first thing we have to think about is how we would connect these. It's DE, so I'll go from D to E. I can't. E to F. F to G. And G back to D, but I can't do that. So I'm going to count the slope from E to F, and then I would repeat that from D to G. Okay, so from E to F, we go down 1 and over 1, 2, 3, 4, 5, 6. Now, I can't actually go down 1 over 6. I'm going to have to do the opposite. I'm going to have to go left 6 up 1. 1, 2, 3, 4, 5, 6 up 1. So it should be right here. We're going to graph this, see if it looks right. If it doesn't, if we've messed something up, we'll have to refix or recount. Let's see. Okay, is this really down 1 over 1, 2, 3, 4, 5, 6? Yes. Is it really up 1, 2, 3 over 1, 1, 2, 3 over 1? Yes, so I've done it correctly. So D is located at -3, -1. All right, there is your slope and parallel lines. We've proved that things are trapezoids and parallelograms. Work on the assignment that is in Google Classroom.